Hi, in this video I'll be going over the graph and quadratic equations test review. For number 1, you are asked to state a lot of the key features. So to get started, you are asked to find the vertex, which is located at the turning point of the graph. This is a maximum point, and its coordinates are 2, 1. The axis of symmetry is the line that divides the parabola into two symmetric halves, and that is always x equals the x from the vertex. You can see it goes through 2 on the x-axis, so x equals 2. The y-intercept is where the graph crosses the y-axis, and that occurs at 0, -3. These solutions, remember, are synonymous with x-intercepts or roots or zeros. In other words, where the graph crosses the x-axis, and that occurs at 1, 0 and 3, 0. This vertex is a max point, and the maximum y value is the y from the vertex, so that its max value is 1. So max 1, here this x is 2. The domain are all possible x values on a function. If the function goes left and right forever, then the lowest x value is -infinity and the highest x value is +infinity. Remember that range is your lowest y to your highest y. Your lowest y, because the graph goes down forever, is -infinity, and the highest y value is 1. And close that with a bracket. To do increasing and decreasing intervals, remember it's best to write infinity ordered pairs because this arrow goes down forever in quadrant 3, going down and left forever. All coordinates in quadrant 3 are negative and negative. The infinity ordered pair would be -infinity to +infinity. On the right side, because this arrow will go down and right forever in quadrant 4, the x values are +infinity and y values are -infinity. Now remember to circle your x values because that will help you identify the values you use to write your intervals of increase and decrease. Now put your finger on the left arrow and trace it from left to right. When we trace it from left to right, we see that it increases first. So it increases from -infinity to 2. So over here at increasing interval, I'll write -infinity to 2. It decreases from 2 to infinity. Notice we have a -infinity and a +infinity and the number 2 repeating, always using our x value. Never use your y's to write increasing, decreasing. So you might want to write a note, use x's. All right, so we're going to do similar with this graph for number 2, stating domain range in our intervals of increase, decrease. Remembering that your domain is your lowest x to the highest x, again, because it goes left forever and right forever. Domain is -infinity to +infinity. Our range is our lowest y to the highest y, the lowest y being -9, and the highest y, because it goes up forever, being +infinity. So -9 inclusive to infinity. So make sure you put a bracket around the -9. Next, again, for our infinity ordered pairs, this arrow will be going left and up forever in quadrant 2, where our x values are negative and our y values are positive. This arrow goes up and right forever in quadrant 1, where our coordinates are positive, positive. Again, circle the x values to write your intervals of increase, decrease, and trace from left to right. When we trace it from left to right, we see that the graph decreases first, then increases. So it will be decreasing on the interval from -infinity to 1. So I'm going to go in my decreasing blank. So skip the increasing. Go to decreasing. It decreases again from -infinity to 1. It then increases from 1 to +infinity. For number 3, you are simply asked to identify some vocabulary and fill in the blanks here using this word bank. A vertical line that divides the parabola into two symmetric halves is called the axis of symmetry. If you want to abbreviate this AOS, that would be fine as well. The blank is the highest or lowest point on a parabola and is referred to as the turning point. I referenced that when we were talking about number 1. That is our vertex. A blank is the shape of the graph that a quadratic function makes. That shape is a parabola. Solutions, zeros, or roots are all names for the, if you think about the other word, the x-intercept of the graph, where it crosses the x-axis. And lastly, the blank is the point where the graph crosses the y-axis. That would be the y-intercept. For number 4, it says there are different properties for the a value in a quadratic function. List them below. What we know is that in a quadratic function in the form y equals ax squared plus bx plus c, or it could be vertex form or factored form, the a value determines whether the parabola opens up or down. If a is positive, the parabola opens up. If a is negative, the parabola opens down. Now it says which key features are easily obtainable from the following forms of quadratic equations. You might need to write down the function in each form to help you recall. Standard form is y equals ax squared plus bx plus c. But in standard form, what we know is that the constant term is the y-intercept. So you need to write constant term is y-intercept, the ordered pair 0, c. We also know that the direction of opening based on the a value. Positive a up, negative a down. Vertex form is y equals a times the quantity x minus h squared plus k, where what we know is that our vertex is the ordered pair hk. And again, because we also have the a value again, we know the direction of opening. Again, positive a up. If a is negative, down. Factored form is y equals a times the quantity x minus x sub 1 times the quantity x minus x sub 2. What we know is that our zeros are found from setting the factors equal to 0 and solving. So our zeros are x1, 0, and x2, 0. And again, because we have the a value, we know the direction of opening. All right, for 8 through 13, you're now asked to write a quadratic function using the most efficient form. So that means if we give you a y-intercept, you should know that here the constant term is the y-intercept, so we should use standard form. So our equation should look like this when we get done. You're given the a value to substitute in for a as well, so make sure you do that as well. So for 8, you would have y equals, I am not going to write the understood 1. I'll let you see that we're putting it there. But, it would be an understood 1, x squared, plus x. And again, you could pick a different b value if you like. Right now it's an understood 1. But our y-intercept, because we have a negative 7, that is our c. we must put a negative 7 at the end of our function. But of course, these ones are understood. All right, for number 9, you're giving x-intercepts. Remember, x-intercepts are zeros, and they're found from saying the factor is equal to 0 and solving. So you basically kind of think working backward. So y equals the a value, which is 3, times the quantity x minus, this would be our x sub 1, and this is our x sub 2. When we write our factors, it's always x minus the 0. And over here, when we do x minus negative 5, we'll end up adding right here because we have subtracting a negative. So again, it's y equals 3 times the quantity x minus 3 times the quantity x plus 5. For number 10, our a value is negative 2. Again, if I have x minus negative 2 and x minus negative 6, I'll have the quantities x plus 2 and the quantity x plus 6. I want to say actually that this one got changed and it was the origin and negative 6, 0. If that's the case, then it would be y equals our a value of negative 2. And I'm just fixing this in case that was my mistake in printing a copy that had the wrong value, because I'm pretty sure we did one that had origin. Remember, if we have an ordered pair at the origin or 0 at the origin, it would be x minus 0, then the quantity x minus negative 6, but then we would have to clean that up and leave it as x, because x minus 0 is x, and then subtracting a negative would give us x plus 6. So that would be our answer in case that one was changed. My apologies. On number 11, we'd have y equals negative 1/2. And then it's in vertex form, so we would then have the quantity. So vertex form again looks like this. We have a quantity squared where it's x minus the h value plus the k value, which is 4. So we've got minus a negative again. Remember to switch keep. So when we switch it, it ends up being positive 2. And then we keep this positive 4. Sorry, don't know why I put the parentheses. Next, our vertex here for 12 is at 3, 8. So again, y equals, in vertex form, negative 1/4 times the quantity. Remember, it's x minus the h squared plus k. You're just sticking the a in front. So y equals negative 1/4 times the quantity x minus 3 squared plus 8. And then lastly, it passes through the point negative 3, 2 and 4, 2. This is the one where you recall that if the y's repeat, we are going to write it in factored form. We've got an a value of 4. So passes through the points negative 3, 2. So x plus 3 times the quantity x minus 4. And then we add 2. So last thing I want you to do before you finish this section is type all these in and verify that they go through the given point. So for number 8, go type in x squared plus x minus 7, and it should go through the point 0, negative 7, and it does. For number 9, let's type in 3 times the quantity x subtract 3 times the quantity x plus 5. If I'm going too fast, just pause the video. Go to the table, and we should see the order pairs 3, 0 and negative 5, 0. Next, negative 2 times the quantity x plus 2 times the quantity x plus 6. Look at the table, and we should see the order pairs negative 2, 0, and negative 6, 0. So that's good. Vertex form for number 11, your a value of negative 1/2 times the quantity x plus 2 squared plus 4 Going to our table, we should see the order pair -2, 4. And we do. Next, for number 12, -1 4th times the quantity x subtract 3 plus 8. And we should see the order pair 3, 8 for our vertex. So we're good. And I knew something was wrong. All right, I forgot my squared. Sorry about that. So 3, 8. I'm looking for that symmetry on either side here of my vertex to make sure it's correct. All right, so that's correct. And next, 4 times the quantity x plus 3 times the quantity x minus 4 plus 2, -3, 2, and 4, 2 is on our table. So our functions are correct. In the next video, I'll be covering the graphs on the back page.